The grid goes down on a Tuesday morning in late September. No dramatic announcement, no warning sirens, just silence where the hum of refrigeration used to be. Within 48 hours, grocery store shelves in major metropolitan areas are stripped bare. Within 5 days, civil unrest begins in earnest. Within 2 weeks, the average American household has exhausted its food reserves. The cascading failure isn't caused by the lack of food in the national supply chain. It's caused by the fact that 98% of American food production depends on systems that cannot function without continuous electrical power, fuel distribution, and industrial chemical inputs. The entire model collapses the moment any single support pillar fails. And here's what almost no one talks about. The survival garden advice you've been given is designed for a world that still exists. It assumes you'll have access to seed suppliers, municipal water, garden centers, and neighborhoods where hungry people won't notice your thriving vegetable rows. Those assumptions evaporate within 72 hours of a real breakdown. Most preppers build gardens that look impressive in May but become liabilities by August. They plant 40 tomato plants in raised beds, run drip irrigation from city water lines, and assume they'll harvest enough to can for winter. This approach has a fatal flaw. It's visible. It's labor-intensive. It requires inputs you won't have. And it produces food in concentrated bursts that attract attention during the exact period when you need to stay invisible. The real question isn't how to grow food, it's how to grow food in a way that remains operationally secure, resource-independent, and productive across multiple years without resupply. That requires understanding the 5 garden architectures that actually survive systemic collapse. Not the ones that look good on social media, the ones that keep producing when everything else has stopped. Let's start with the first lie. The idea that you should grow annual vegetables in visible rows. This advice comes from an era when food production was a community activity, when neighbors helped neighbors, and when theft wasn't a survival imperative. That world no longer exists in a collapse scenario. In any prolonged crisis, visible food production becomes a tactical vulnerability. People will notice, they will remember, and when their children are hungry, they will come, not out of malice, out of desperation. The solution isn't to stop growing food, it's to grow it in configurations that don't announce their presence. This is where the forest garden model becomes critical. Unlike traditional gardens, forest gardens mimic natural ecosystems. They use vertical layering, canopy trees, understory trees, shrubs, herbaceous plants, ground covers, root crops, climbing vines, all integrated into a structure that looks like wild woodland to the untrained eye, but every plant is edible or serves a support function. The genius of this system is that it operates on ecological principles that don't require external inputs. No tilling, no fertilizers, no pesticides, no irrigation infrastructure. The canopy layer shades the soil and reduces water evaporation. Nitrogen-fixing plants like black locust or autumn olive feed the system naturally. Deep-rooted plants pull nutrients from subsoil layers that shallow annuals never reach. Leaf litter builds humus year after year. The system becomes more productive over time, not less, and critically, it's almost invisible. A mature forest garden looks like a neglected thicket. Neighbors walking past won't see food, they'll see brambles and weeds, but you'll know that every square meter is producing calories. Hazelnuts in the shrub layer, ramps and wild ginger at ground level, ground nuts in the root zone, grapes and hardy kiwis climbing through the canopy, apples and pears in the overstory. This isn't a garden you harvest once a year, it's a perpetual food system that produces across 8 months of the growing season. Here's the second lie, that you need good soil to grow food. This assumption stops people before they even start. They test their soil, find it's clay or sand or contaminated, and assume gardening is impossible without truckloads of compost and amendments. This is backward thinking. The most resilient food systems are built on the worst soil because they're designed to create soil, not depend on it. This is where the hugelkultur method becomes essential. The term comes from German permaculture and translates roughly to mound culture. The technique involves burying large volumes of wood beneath your growing area. Logs, branches, twigs, even whole trees if you have them. You stack them in trenches or long mounds, then cover them with organic matter and soil. The wood acts as a sponge, absorbing rainfall and releasing it slowly during dry periods. As it decomposes over 5 to 20 years, it feeds the system with nutrients and creates fungal networks that transport water and minerals to plant roots. A properly built hugelkultur bed requires zero irrigation after the first season. Even in drought conditions, the buried wood holds moisture. Even in nutrient-poor soil, the decomposition process feeds your crops. And because the mounds are raised, they drain well and warm up faster in spring. You gain 4 to 6 extra weeks of growing season. The strategic advantage goes deeper. Hugelkultur beds can be built on land that's otherwise useless. Slopes, rocky ground, compacted clay, it doesn't matter. You're not trying to improve the existing soil, you're building a new soil ecosystem on top of it. This makes it possible to establish food production in areas that would normally require years of soil amendment. In a collapse scenario, you don't have years. You have one growing season to establish a system that will keep producing. Hugelkultur gives you that capability. Now let's talk about the third lie, that root cellars are the only way to store food without electricity. Root cellars work, but they require specific geography. You need a hillside to dig into, or a basement with the right temperature and humidity. Most people don't have that, and even if you do, root cellars have a visibility problem. They're permanent structures. They require excavation. They leave evidence. In a scenario where people are searching for food, a root cellar is a target. The alternative is something almost no one talks about: buried cache storage using sealed containers. This method comes from military logistics and Cold War prepping. The concept is simple: food-grade buckets with gamma seal lids buried 18 to 24 inches below ground create a stable temperature environment that preserves dried goods for years. The soil acts as insulation. Summer heat doesn't penetrate, winter cold is moderated, and most importantly, the cache is invisible. Here's how it works in practice. You take 5-gallon buckets and fill them with rice, beans, wheat berries, dried corn, or any low-moisture staple. You add oxygen absorbers to prevent oxidation and insect activity. You seal the lids. Then you bury them in locations you've memorized or marked with natural features, not all in one place, distributed across your property in a pattern only you understand. Each bucket represents 2 to 3 weeks of calories for one person. 10 buckets is 6 months of baseline food security. The strategic advantage is that even if someone discovers your garden or your home, they won't find your primary food reserve. It's underground, unmarked, distributed, and it doesn't require any structure that can be identified from aerial surveillance or casual observation. The fourth lie is about water. Most survival garden advice assumes you'll have access to a well or municipal supply. That assumption fails immediately in any grid-down scenario. Wells require electricity for pumps. Municipal systems fail within days when treatment plants lose power. Rainwater catchment is the standard answer, but it has a fatal flaw. Barrels and tanks are visible. They announce that you have a water source. In a prolonged crisis, water becomes more valuable than food. People will come for it. The solution requires thinking about water the way hydroelectric engineers do, not as something you store, but as something you manage through landscape design. This is where swales and infiltration basins become critical infrastructure. A swale is a level-bottomed ditch that runs along contour lines. When rain falls, water runs downhill until it hits the swale, then spreads out and soaks into the ground instead of running off. This does 2 things. It prevents erosion, and it charges the groundwater table beneath your garden. In a well-designed system, you're not catching rainwater. You're storing it underground where no one can see it. The water infiltrates through the soil profile and moves laterally through the root zone of your plantings. Trees and perennials send roots down to access it. Your garden stays hydrated through dry periods without any visible irrigation system. The military calls this passive water harvesting. Permaculture designers call it earthworks. Either way, it's invisible infrastructure that keeps working when everything else has stopped. And it costs nothing but labor. You dig the swales once using hand tools. After that, they function automatically every time it rains. Over the course of 5 to 10 years, this approach can raise the water table across several acres. You're not just watering your garden, you're transforming the hydrology of your entire property. Here's the fifth and most important lie: that gardens need to be separate from living areas. This idea comes from industrial zoning logic. Food production happens in fields, houses are in residential zones. The two don't mix. But in a collapse scenario, separation is a tactical error. If your garden is 50 meters from your house, you can't defend it at night. You can't monitor it continuously, and you can't respond immediately to threats. The solution is to integrate food production directly into defensive architecture. This means planting your garden inside your security perimeter, not outside it. This means using edible perennials as living fences. Hawthorn, rugosa roses, blackberries, and honey locust create barriers that are both defensive and productive. They grow dense, they have thorns, they're difficult to move through, and they produce food. A mature hedge of these species becomes a physical barrier that slows or stops intruders while providing berries, rose hips, and honey locust pods that are all edible. This approach does something psychological too. It changes the visual signature of your property. Instead of looking like a fortified compound, it looks like an overgrown, abandoned lot. That's exactly what you want. In a crisis, the properties that get hit first are the ones that look like they're being actively defended. The properties that survive are the ones that look like they've already been looted. Strategic neglect becomes camouflage. But behind that facade, you've built a productive ecosystem that feeds you while keeping intruders at a distance. The technical term for this is defense in depth through landscape architecture. You're not building walls, you're building layers of productive vegetation that serve multiple functions simultaneously: security, food production, visual concealment, water management, soil building, all happening at once in the same physical space. Now we need to talk about seed genetics, because this is where most people make a catastrophic mistake. They stockpile hybrid seeds from commercial suppliers and assume they're prepared. They're not. Hybrid seeds are bred for uniformity and high yield, but they don't breed true. If you save seeds from hybrid plants and replant them, you get genetic chaos. Some plants will produce, most won't. Your seed stock degrades after one generation. This is by design. Seed companies want you to buy new seeds every year. That business model works fine when civilization is functioning. It fails completely when supply chains collapse. The solution is to build your seed stock exclusively from open-pollinated and heirloom varieties. These are varieties that have been stabilized over generations. When you save seeds from open-pollinated plants and replant them, you get plants that are genetically identical to the parent. Your seed stock is self-renewing. You never need to buy seeds again. But here's the part most people miss. You can't just buy heirloom seeds and stick them in a freezer. You need to grow them, adapt them to your specific microclimate, and select for traits that matter in a collapse scenario. Not yield, not appearance, not market value. You're selecting for disease resistance, drought tolerance, pest resistance, and the ability to produce without fertilizers or irrigation. This is called seed saving with intentional selection pressure. Every year, you plant your crops. You observe which plants perform best under stress. Those are the plants you save seeds from. Over 5 to 10 years, you develop locally adapted strains that are optimized for survival conditions, not industrial agriculture. This isn't something you can do after the collapse starts. It takes years, which means you need to start now. Let's connect these 5 systems into a unified operational framework. You're not building a garden, you're building a food production infrastructure that remains functional and secure across multiple years of systemic failure. The forest garden provides perennial calories and operates with 0 inputs. The Hugel culture beds give you annual crops on any soil type without irrigation. The buried cache system stores your staple calories in a distributed network that can't be located or confiscated. The earthworks manage water invisibly and recharge the root zone year-round. The integrated security perimeter uses productive thorny perennials to create defensible space that doesn't look defensive. And your seed stock is genetically stable and adapted to local conditions. These systems overlap and reinforce each other. They're not separate projects, they're layers of the same strategy. Here's what this looks like in practice during year 1 of a collapse. Your neighbors are panicking because their freezers have thawed and their pantries are empty. You're not panicking because you buried 6 months of staples 2 years ago. You're harvesting early greens from your hugelkultur beds in March because the wood inside is creating bottom heat. You're eating ramps and wild leeks from the forest garden understory, while everyone else is still waiting for their tomato seedlings to sprout. By June, your thorn bush perimeter is loaded with berries. By August, your hazelnut shrubs are producing. By September, you're digging potatoes and harvesting apples. And through all of this, nobody notices. Your property looks abandoned. There are no neat rows, no raised beds with fresh lumber, no rain barrels, no greenhouse, just tangled vegetation that any passerby would assume is worthless scrubland. This approach scales. If you have a 1/4 acre, you can produce 70% of your calories using these methods. If you have 5 acres, you can produce for an extended family and have surplus for barter. The labor requirement drops over time because perennial systems maintain themselves. Year 1 is hard work. You're digging swales, burying wood, planting trees and shrubs. Year 2 is moderate. You're mulching, pruning, planting annuals in the hugelkultur beds. Year 3 and beyond, the system is mostly self-managing. You're harvesting, saving seeds, and doing minor maintenance. The forest garden canopy closes, the understory fills in. The whole system becomes a self-sustaining organism. There's a broader pattern here that almost no one talks about. The reason modern food systems are fragile isn't because we lack technology. It's because we've built them on models that require continuous industrial support. Fertilizers from natural gas, pesticides from petroleum, seeds from centralized suppliers, irrigation from electric pumps, distribution networks that move food thousands of miles. Every one of these dependencies is a single point of failure. When any one breaks, the whole system staggers. The solution isn't to stockpile inputs, it's to build systems that don't need inputs. That's what these 5 setups do. They eliminate dependencies. They run on rainfall, sunlight, and biological processes that don't stop when the grid goes down. Here's the final thing you need to understand. The time to build these systems is before you need them. Not because you think collapse is imminent, but because building resilient food systems takes years to mature. A forest garden planted today will be marginally productive in year 2, moderately productive in year 5, and highly productive in year 10. Hugelkultur beds need 1 full season to establish microbial networks. Buried caches need to be rotated and maintained. Seed stocks need to be grown out and adapted. This isn't something you can do in a panic. It's something you do methodically, over time, as part of normal life. And if the crisis never comes, you still benefit. You're eating food you grew, you're building soil, you're increasing your property value, you're creating habitat for pollinators and wildlife, you're learning skills that make you more capable and self-reliant. But if the crisis does come, you'll be in a completely different position than 99% of the population. You won't be standing in line at distribution centers. You won't be raiding stores. You won't be dependent on government aid or charity organizations. You'll be eating from systems you built, On land you control, using knowledge you've internalized through years of practice. That's not just food security, that's operational independence. And in a world where food becomes the primary medium of exchange and control, independence is survival. The question isn't whether these systems work. They do. The question is whether you're willing to put in the work to build them before they're needed. Most people won't. They'll wait. They'll assume someone else will handle it. They'll trust that supply chains will hold. And when those assumptions fail, they'll be in the same desperate position as everyone else. You don't have to be. The information is here, the methods are proven. What happens next is entirely up to you.